Welcome back. Today we're going to be talking about this probability model. So assume that we have a square that has side length x, and we construct the middles of each side, and from there we connect them to get another square that's inside the square, the square that's having side length x. Okay, so this model, we say that Presidents Biden and Trump, they throw coins. If Biden throw a coin and it lands on the white square, he wins the election. If Trump throws a coin and it landed on the green square, the green area, he wins the election. So we want to compute the probability for each of them. And basically we want to prove that this model is it fair. So to show that that this model is fair, that means the probability of each one of the presidents winning this election is the same. So since we have two people, let's denote them by T and B. So the probability that Trump wins must be 1/2, and probability that Biden wins must be 1/2, to say that this this is a fair model or a fair election. Okay, we want to prove if we have these probabilities. So the probability for Biden winning is, so it's given by the white area. So the area of the white square over the total area. So the total area is given by the area of the square, which is x times x, which is x squared. The area of the white square is just the area, the side length of the side length times itself. Okay, or we can negate that by saying that, or we can compute it. In fact, we can compute it. It's very simple using the Pythagorean theorem. So we have this one as x over 2, this is x over 2. So we use the Pythagorean theorem to compute this side length, which is going to give us x over 2. X over square root of 2. So this side length is going to be x over square root of 2. To see it, okay, so to see it, let's call this side d. So d is going to be the square root of x squared over 4 plus x squared over 4, which is going to be x squared over 2, which is x over square root of 2. So once we do this, since we have this one as x over square root of 2, so the area, since it's a square, it's going to be x. So it's going to be x square root of 2 times x square root of 2, which is going to give us x squared over 2 over x squared over x squared. So it's going to be 1/2 after simplification. So it's x, oh, my handwriting is bad. So it's x squared over 2 over x squared. So it's 1/2. Okay, for President Trump, it should be the same. Okay, so it's going to be the green. So let's say that Trump wins. So the area of the green squares over the area of the total. So we know the area of the total is x squared. These squares, since we these triangles, since we have 4 of them, we compute the area of one of them. So one of them is the area is 1/2. Let's say the area of one. So x over 2, it's 1/2. X over 2 times x over 2, it's x squared over 8. And since we have 4 of them, so it's going to be 4 times x squared over 8. It's going to be x squared over 2. So here you have x squared over 2 over x squared is 1/2. So we see that in this model, we have the probability of Trump winning is the same as the probability of Biden winning. It's 1/2. Okay, or it's fair. So this model is fair. Some people might argue that choosing this white one is more favorable of Biden winning than Trump. No, it doesn't mean anything. Okay, it doesn't mean anything. So because some people they say throw in the coin, sometimes you're gonna see it on the ad. But we just imagine that. But so that this shows that the probability of one or the other winning the election is 50%. So that means it's fair. So this model is fair. Unless there is something I don't see, you can tell me in the comment. So. And there is another thing that people might argue. So the probability of Biden winning, having been the president, is different from probability of Trump winning, having been president before. So this is a conditional probability, and it's different from this model. So this model doesn't depend on any previous presidentship. It depends on this model. Now we don't take care of the past. We just taking care of this model on the coin. If when I work with this one, it's different. Yes. Thank you.